Hey guys, showing my face just for a little bit here. I'm going to point out that those of you who are watching the videos, thank you so much. You're going to notice that you're going to hear a lot of the same information from me in the classroom, but if you already heard it once on the video, you're going to be much better off than those people who are hearing it for the first time. So, first thing I'm going to recommend is make sure that you are writing down in your notebook all the information that comes with filling in these blank lines. Okay, do that, give a couple of examples, you're going to be good to go. Okay, so keeping that in mind, going to throw out a text box here. Undo addition or subtraction with the inverse operation. We talked about this on one step. It is even more important to do it in two-step because in two-step, you're going to obviously undo two operations. And I want you to think of, remember, we're not doing PEMDAS anymore, but we have GEMS, doing that in the inverse order. So where we were adding and subtracting last, now when we go to two-step equations, we're going to do the inverse of addition or subtraction. We're actually going to do this first. Okay, so after we take care of the inverse of addition or subtraction, we are going to undo multiplication or division with the inverse operation. Okay, isolate the variable, okay, which in most example cases was x. Okay, but it really could be anything. If we're talking about cookies, you could use C and whatever. Okay, and then check your solution, right? Or another way of saying that would be check your answer. And I reminded my classes of this last week. When you go to check your answers, you actually need to type in the whole entire original equation, okay? And then not just write it down, but actually type it into a calculator and let the calculator support your responses. Okay. What we have here is a model demonstration. So I'm just going to use my drawing tool here. We have two boxes with the x variable on them. So a coefficient of 2x. And then we have 4 ones, which is going to represent the constant of adding 4. That's going to be equal because equations are balanced on both sides. 3 on this side. Okay, this is a two-step equation because the first thing we need to do is focus on the constant and combining it with the other one. So I need to get it away from the x, isolating the variable, by inverse operation. If I circled the positive 4, I'm going to cancel it out by doing a negative 4. Do that on both sides. Okay, and I have 3 minus 4, which then is going to leave on this side of the equation a 2x. And over here, 3 minus 4 is a negative 1. Okay, now I'm ready to do the inverse of the multiplication operation that I see so that I can have x all by itself. Okay, and the only way to get x to turn into just an x is to divide by whatever is next to it. Okay, so I am going to divide by 2. Okay, canceling out those 2's. And I have to divide over here by 2. And I'm just going to point out at this point that if I were to write this down again, that would look like x equals negative half. I could truly stop right here. I have my answer. Or I could divide negative 1 by 2, which would give me a negative half or a negative 5/10 as a decimal. A lot of ways to look at it. But what I'm going to do is then again take the original equation, okay, and plug it back in. So they're telling me that x is equal to negative half, so I would take 2 times negative half instead of x, okay, and then I would add 4, and it would equal 3. Well, a negative half times 2 would make the 2 turn into a 1, negative 1. Negative 1 plus 4 is going to turn into a 3. So that is 100% correct. Okay, for the other examples that I'm going to demonstrate, they have 1, 2, and 3. I'm actually not going to demonstrate 1 or 2. I'm going to jump straight into 3. And the reason why is because a lot of times when people look at number 3, they're not sure how to approach it. Again, the first thing you want to do is get the constant, which right now is a negative 8, to the other side. Okay, I want to get rid of it here, so I'm going to have to add 8 so that it cancels it out. That leaves me with just r divided by 2, and that's equal to, balancing both sides of the equation, 16 plus 8 on this side is going to equal 24. Okay, so my new equation, okay, is r divided by 2 is equal to 24. The way to get rid of the divided by 2 is to multiply by 2, canceling those out and simply leaving me r. Okay, and if I do that on this side as well, times 2. 24 times 2 is going to double that and make it 48. Now, had I made the mistake and continued with my division sign that I was writing there, I would have discovered it when I went to check. So I'm going to replace the r in the original equation with what I believe to be the answer, 48. I'm then going to divide that by 2, okay, and then I'm going to subtract 8 from it, and it should equal 16. So you would see me then pick up my calculator, type in 48 divided by 2. I could hit enter at this point and get 24, and then I subtract 8 from that, and it would equal 16. Or, like most calculators, I could type in 48 divided by 2 minus 8, and then hit equals, and it would still give me 16. Okay, so again, tips. You're going to want to get rid of the constants first that are on the same side as the variable, okay, by doing the inverse operation. Second step, you're going to want to get rid of whatever coefficient is next to that variable, whether it means to, in this case, multiply or divide, whatever the inverse operation is. Third step, remember you're doing this on both sides of the equation. Once you've gone through the 2 steps and come up with your solution, okay, the third step is to actually check your work. Take the original equation, plug it in, and see if you are in fact correct. I hope this helps. Watching the videos is going to make all the difference, guys. Good luck.